So start up for week number 6. Number 1 says which angles are corresponding. Now, think about corresponding angles in these terms. If I have a set of parallel lines, and they don't necessarily have to be parallel, but if I have a set of parallel lines, the angles that are in the same location. So if I'm looking at this angle and this angle, those are corresponding angles. So you want to treat it as if you could cut the transversal and pick one intersection up and put it on top of the other one. What angle would be on top of the other? Those are corresponding angles. Corresponding angles are angles that are in the same location. In this case, in the drawing that I have, I'm referring to the angles that are in the upper left corner. These two angles here are also corresponding. This angle and this angle are corresponding to each other. And then finally this angle and this angle are corresponding. So now with question number 1, it says which angles are corresponding angles. There are many corresponding angles in this particular figure and drawing. If we're looking at angle 1, angle 3 and angle 9 are all corresponding to angle 1. If we're looking at, say, angle 15, if we're looking at angle 15, angle 13 and angle 7 would be corresponding. So it depends on what set of lines, whether if it's line AB or line CD, and which is the transversal. So that's the reason why there can be two different ones. If we're looking at, let's say, angle 8, the corresponding angles to angle 8 would be angle 6 and angle 16, because they are in that lower left corner. Understand when you're referring to corresponding angles, alternate interior, alternate exterior, or same side interior angles, you always have to be looking at a pair of lines cut by a transversal. So that's the reason why if I'm using angle or line D as the transversal, the corresponding angle to 8 would be 16. However, if we were using, let's say C, no, what if we looked as A being the transversal and C and D being the parallel lines, then 6 is corresponding to 8. Notice that you have to have one line touching both angles, and that is the reason why an angle such as 8 and 14 are not corresponding, because they do not share a common line. Number 2, it asks you to graph an equation. That equation is negative 4x plus 7 equals a negative 28. Now, a couple of ways that we can graph this. One, we can graph it by using properties of standard form, or if you want to put it in slope-intercept form, that is perfectly all right. But most often, when it is in something that resembles standard form, and the reason why I say it resembles is because standard form, A is not negative. A is always going to be positive when it is in a true standard form. But we can still go on with what we have. If we're looking to graph and it's in standard form, I would always graph by intercepts, meaning if I'm looking for my x-intercept, that means y equals 0. And if I'm looking for my y-intercept, x equals 0. So plug it in. If I'm looking for x-intercept, y is going to equal to 0. That gets rid of that portion of the equation. Solve what you have left. We have negative 4x equals a negative 28. If I solve for x, x equals 7. So on my graph, I'm going to go over 7 places. I'm going to put a dot at my x-intercept of 7. And then I'm looking for my y-intercept, so I'm going to plug 0 in for x. Maybe some of you have heard this as being the cover-up method. Cover up the variable that you're not looking for. If I'm looking for y, I'm going to cover up the the term that has the x in it. And so now I only have 7y is equal to a negative 28. So y equals negative 4. So I'll put a point there. And when I have that point placed, I will then connect the dots as best as I can. And there's the equation of that line for negative 4x plus 7y equals negative 28. If you want to put it in slope-intercept form where you're solving for y, and you can identify your y-intercept and your slope, perfectly all right. Choose your method to solve for. Let's move to number 3 and 4. 3 and 4 says write an equation of line parallel to y equals a negative 7x plus 15 that contains the point P, 9, negative 6. Now understand, when we're talking about parallel lines, if we're looking at those, slopes are the same. So then I'm looking at my line up here, and I need to find out what the slope is of that line. For that line, slope equals negative 7. So then the line that's parallel to it, the slope, and I like to call it parallel slope, would equal negative 7 as well. I have a point at 9, negative 6. So I'm going to plug that into point slope. Point slope is y minus y1 equals m times x minus x1. So I have a point, I have a slope, so I'm going to plug it in. Y minus a negative 6 equals negative 7 as my slope of x minus 9. Now it doesn't ask me or tell me what form to put it in. So technically I'm done. It just says write an equation. That is an equation of line that is parallel and going through the point of 9, negative 6. If it asks me to solve for slope-intercept, I'm going to solve for y. Distribute, move everything, and get y by itself. If I have to put it in standard form, I'm going to distribute and get x and y on the left-hand side. All right, so with number 4, it says write an equation of line perpendicular to y equals 2x minus 5 that contains the point negative 9, 6. Now, it's very similar to number 3, except for the one change. Instead of being parallel, we are now looking at being perpendicular. Now, if parallel lines, their slopes are equal to each other. With perpendicular, we flip it and we change its sign. So first of all, my slope for this line is 2. So my perpendicular slope, now understand this is 2 over 1. I'm going to flip it, the fraction, and I'm going to change its sign. So it was a positive 2, so that means my perpendicular slope will be a negative 1/2. So once again, I have a slope, I have a point. So I'm going to put that in point slope form. Y minus y1 equals m times x minus x1. Y minus 6 equals a negative 1/2 x minus a negative 9. So remember, if it just says write the equation of line, we are technically finished. We're done with that problem. But what if this said, hey, let's put this in standard form? So if I have to put this in standard form, I have to distribute the negative 1/2. But we don't like fractions, so we have, remember, what we call trouble. Top right, bottom left. I'm going to take this top number and I'm going to multiply it to everything on the right hand side. So negative 1 is going to be multiplied to x. Negative 1 is going to be multiplied to 9. So it gives me negative x minus 9. And then I'm going to take the bottom number and I'm going to multiply it to the left, to both terms. So 2 times y is 2y minus 12. So I have 2y minus 12 equals a negative x, negative 1x minus 9. In order to put that in standard form, I have to get x and y on the same side. So I'm going to take that negative 1 and I'm going to move it over. And the way that I move it over is by changing its sign. I'm going to keep the 2y where it is. If I move the negative 12 across, that becomes positive 12. So 12 minus 9 gives me 3. So there gives me the standard form of the equation of the line. Because why? A and B are both not zeros. Everything are integers. And A is also positive. Do we have to put it in standard form? In this particular problem, it doesn't tell us to, but we chose to. Number 5. Number 5, are the lines parallel, parallel, perpendicular, or neither? And they give us two lines. We have y equals a negative x minus 4, and we have 5x plus 5y equals 20. So we want to determine if they are parallel, perpendicular, or neither. So in order to do that, we have to find the slopes of both lines. Once we find the slopes of both lines, let's compare them. If the slopes are the same, they're parallel. If the slopes are negative reciprocals of each other, they're perpendicular. If they're neither one of those, then they're neither parallel nor perpendicular. So for this line, my slope is the coefficient of x, which is negative 1. For this line, that is in standard form, and we have a shortcut that slope equals a negative a over b. Negative a over b. So I'm going to take the negative of whatever a is. In this case, a is 5. I'm going to put it over b, which is also 5, and I'm going to reduce. It gives me a negative 1 over 1. So let's compare the two slopes. Here I have negative 1, and remember, it's understood as being over 1. And here I have a negative 1 over 1. So as we compare them, we see that the slopes are the same. If the slopes are equal, that means the lines are parallel. If the slopes were negative reciprocals of each other, that means that the lines would be perpendicular. Let's look at number 6. Number 6 says to find the value of the variable. If M is parallel to L, measure of angle 1 equals 2x plus 44, and the measure of angle 5 equals 5x plus 38. The diagram is not to scale. So we're told in our directions that M is parallel to L. They're parallel to each other. And we're told a value for angle 1, which is right here. And we're told a value for angle 5, which is right here. So we have to determine what type of angles those are. Are they corresponding, alternate interior, alternate exterior, or same side interior? In this case, they are corresponding. If two parallel lines are cut by transversal, corresponding angles are congruent. So if angle 1 is congruent to angle 5, that means the measure of angle 1 will be equal to the measure of angle 5. So I can substitute in 2x plus 44 equals 5x plus 38. And I'm going to solve for x because it says find the value of the variable. If the 2x goes across, that means I subtract it, so that gives me 3x. 5x minus 2x. If I take the 38 across, I'm going to be subtracting it from 44. 44 minus 38 is 6. Dividing both sides by 3, x equals 2. And that finishes our startup for week number 6.